Okay, welcome back to the channel. Now, we've got a lesson on linear inequalities, and many of you will have seen these before anyway at GCSE. So hopefully a lot of this will be quite familiar to you. Now, to solve these inequalities, what we do is treat the inequality sign as if it was an equal sign for the most part. And so to solve the first one, let's just start by writing out the inequality. There you go, 2x minus 3. And then what we'll do is we'll minus the 2x to this side. So we have 4x minus 14 is greater than or equal to minus 3. Next, take the minus 14 over to that side. So we'll have 4x is greater than or equal to 11. And then divide by 4. So x is greater than or equal to 11 over 4. Or 2.75 if you leave it as a decimal. So what we've done here is we've left our answer as an inequality, but they may ask you to leave your answer in set notation as well. So how do you do that? Well, actually, it's very similar to this anyway, except you just want to open up some brackets, and then you say x is bigger than or equal to 11 over 4. And then you close off your bracket, and that's it there. That's how you're going to represent that using set notation. Now let's do the same for the second inequality. Let's go and solve it first. So x minus 5 is less than or equal to 3 minus 9x. So I'm going to bring the 9x across. So we've got 10x minus 5 is less than or equal to 3. Add the 5 over. So we've got 10x is less than or equal to 8. And then we'll have x is less than or equal to 8 over 10. So that's 4/5. And so there again, we've solved it and we've left it as an inequality. But if we wanted to give this in set notation, then we give it like this. And then x is less than or equal to 4/5. And that's how we leave it. Now for part 3, we've got to find the set of values of x for which these two inequalities are true. So to begin with, what we need to do is actually solve both of these inequalities separately. So we'll start by solving this one on the left. So I'm going to take the 2x over to this side. So then we'll have 2x minus 7 is less than 6. Send the minus 7 over, so we'll have 13 and then 2x on this side, and then divide by 2. So we'll have x is less than 13 over 2. So we've got one of our inequalities solved. Now let's go and solve the next one. So we'll take the minus x to this side. So we'll have 3x plus 4 is greater than minus 2. Subtract the 4 over to there. So we've got 3x is greater than minus 6. Then divide by 3. So x is greater than minus 2. Okay, fab. So we've got our two answers. Now there's a few different ways we could leave this. Now what I want to do is maybe draw or represent this on a number line. So let me just draw a number line here. And so far the answers we've got are minus 2 and then 13 over 2, which is basically 6.5. There we go. And so if I had a number line where this is 0, I could say maybe, here's minus 1, minus 2, minus 3. And then for this side, we'll say 1, 2, 3, 4, 5, 6, and then 7. So, bang in the middle of those is going to be 6.5. So the two inequalities you've got is, well, x is greater than minus 2. So what we can do is represent that with open circle and then any value going in that direction, because all the values there are bigger than minus 2. And then for this one, we've got x is smaller than 6.5. So 6.5 is in here, bang in the middle, and it's everything going this way. Here we go. So now to represent this, what we can say is that our x values need to be smaller than 6.5, going that way, but then they also need to be greater than minus 2, because that's the only region where the two lines kind of overlap each other. That's going to work for our inequality. So there it is. There's our answer left as an inequality. But then we could write this in set notation as well. So in set notation, the way we write this is like this. We could go open bracket, x, and then we have minus 2 is less than x, where x is less than 6.5. And then we can leave it like this. Perfect. You could also put them completely separately if you wanted to as well. And if you wanted to leave them separately, then we could do this. We could say that, oops, so it's tricky to draw. So we say the x values there need to be greater than minus 2. And then because this is where the two lines overlap, you can use an intersection sign like this. And then you have x on this side, and then x is less than 6.5. And then you close that off like that. So just remember, because it's where the two inequalities overlap each other, we can use an intersection sign between the two sets to show that it's that part that we're referring to. Okay, so last one down here, again, let's just solve both of them individually, and then we can put them together into one inequality, or we can represent it as some sets as well. So for this one, what we could do is, well, subtract the 3 across, so we can have a quarter x is less than or equal to 3, and then multiply by 4. So x is less than or equal to 12. And then for this side, we'll add the 5 over, so 3x is greater than or equal to 15, and then divide by 3. So x is greater than or equal to 5. So for this one as well, what we'll do is I'm going to draw a number line. So 5 and 12. So we're kind of looking at maybe 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we'll go up to 14. There we go. So what we're told here is the x values here need to be bigger than or equal to 5. So that, and then going off in that direction there. Or the x values need to be less than or equal to 12. So 12 is there. And then continuing that way there. So to leave this as just an inequality, well, we could say that the x values need to be less than or equal to 12, or greater than or equal to 5. That's that done. But now also we can represent this using some set notation. So we could put it together and say basically this same thing here. So 5 is smaller than or equal to x, and x is smaller than or equal to 12. Or we can put them using this notation here, and then it will be the first part here, x is, we'll put greater than or equal to 5. And again, because it's where these two lines intersect each other, intersection, and the other part was x is less than or equal to 12. So there we go, we've represented it there separately as well. So you can put it all together, one big set, or two separate ones over there. Perfect. So that's how you solve your linear inequalities, and you can leave them as inequalities if you want, or you can represent them using some set notation. So hopefully that's all clear, and I'll catch you in the next video.